Hi, hope all's good with you. Okay, so the 2023 paper 2. Okay, let's do a talk through. So let's have a look. Question 1. Circle the clock that shows 5 minutes past 11. Okay, so the hour hand is going to be about on 11. So let's think that that's 12. That's 3, 6, 9, 10, 11. That's my 11. The hour hand is the short one. So it's not going to be this one because that hand is pointing at the number 2. It's not going to be this one because the hour hand is pointing at the 1. It's not going to be this one because the hour hand is pointing at the 1. So it's a circle, right? Okay, so it's going to be this one. Right, let's go down. Right, let's just drag that over here a bit. Okay. All right, so write these temperatures in order, starting with the lowest. Let's check the cursors over here, hiding. All right, so let me think. If I was to draw a line, it's a bit wiggly. That's 0 degrees. So it's going to be -1 and so on that way. And it's going to be a +1, say degrees centigrade, that way. Let's have a look. -4 is going to be about here. 6 is going to be about here. 1 is there. -10 is going to be somewhere down here. And 3 is going to be about here. Let me just check. So we've got, let's look in a bit. We've got 6, +6, and -4 is below 0. Then 1, -10, and 3. Okay, so lowest, that's going to be -10, and then it's going to be -4. And what have I got next? Have I got a 1 and 3 and 6? Great stuff, well done. Let's go this one. And just put the cursor up here. All right. What are the coordinates of point C? Okay, I'm just going to change the colour. Point C is this one. So I know that it's X and then Y. And the X is a cross. Now you could see the word across like this, or you could think X is a cross. X is a cross, X is a cross. Okay, which means that way, doesn't it? And then I used to put on the board this, and that Y has got a long tail. So Y is up and down. I always used to say you have to go towards the stairs. So you've actually got to move along somewhere. You've got to walk along somewhere before you can go up or downstairs. So X goes first. So I look along there and X is 6. So the Y coordinate is here, which is a 2. So the X goes across to the 6 and up to the 2. So you can count, if you want to go across and then up, you can go 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. and that's underneath where the C is, and then you can think 1, 2 up. Okay. Number 4, some children choose their favourite zoo animal. The pictogram shows the results. Now we've been given a key, and this circle stands for 2 children. So let's just have a look. So 2, 4, 6 children chose a penguin. 2, 4, wonder what half, do you think half a circle means half of 2? Yeah, so that's equal 1. Okay, equals 1. So we've got 2, 4, 5. And we've got 2, 4, 6, 8, 10, 12. And we've got 2, 1. So that's 2 plus 1 is 3. How many more children choose tiger than elephant? Okay. So elephant is 5. And tiger is 12. And what's the difference between these two numbers? Elephant's 5, tiger's 12. It says tiger and elephant. How many more children choose a tiger than an elephant? So that's 12. Take away 5, or the difference between 12 and 5. And that's what we're doing. We're doing 12 take away 5, which is 7. Okay. You could start at 5 and count on 5, 6, 7, 8, 9, 10, 11, 12. Okay, well done. Explain why Stefan cannot be correct. Okay, let's have a look. So, cars, he counts 5. And motorbikes, he counts 3. Now it says cars have 4 wheels, so we've got 5 lots of 4 here. And motorbikes have 2 wheels, so it's 3 lots of 2. So 5 times 4 is 20. 3 times 2 is 6. So altogether there should be 26 wheels. So let's just double check. Car has 4 wheels. There are 5 cars, there's 20 wheels. There are 3 motorbikes, and each motorbike has 2 wheels, so it's 3 times 2 is 6, so it's 26. He counts 28 wheels altogether. Explain why Stefan cannot be correct. What shall I put? Stefan can't be correct because there are 20 car wheels and 6 motorbike wheels. (20 plus 6 is equal to 26 wheels altogether. You could put this sort of thing with it if you had the space. This is reduced. This is small. This is a smaller sort of version of the question, and your handwriting won't be as big as mine, so you will have more space. Let's have a look at number 6. So we have Kirsty buys 1 litre of apple juice. So 1 litre of apple juice for £1.39. So 1 litre, and it's apple juice, and 1 litre costs £1.39. Ooh, very curly there. Okay, she pays with a £5 note. How much change does Kirsty get? All right, so a £5 note, if we're writing it in pounds and pence, is 5.00. And we're looking at the difference between £1.39 and £5. So I'm going to take away £1.39. Don't actually need all of that there. So we have 0 take away 9 and 0 take away 3. So what we've got to do is move a digit down. So we turn that into a 4, and because that's £4 and £1, we need to take that 1 there. We can't jump it all the way down. Cross the 10 out, turn it into a 9 and carry 1. Now we've got 10 take away 9 is 1. 9 take away 3. Difference between 3 and 9 is 6. And 4 take away 1 is 3. So that's £3.61. The other way of looking at it is you could count on. So you could start with £1.39 and you could count up to £5. Let me just change colours so it's a bit clearer. So what I would probably do is I'd probably put £2 here. And then I'd do a jump plus £3 here. £2, add £3 is £5. So I've got to work out what this bit is. So I might even, if I need to, put another part of it in. So £1.39. I might then put £1.40 here and make it a little bit easier again. And let's just extend that. So £1.39 add what is £1.40? That's add 1 pence, isn't it? 39 pence add 1 pence is 40 pence. You could, if you want to, write like this. That's the same. And then 40p add what is a pound? So 40, 50, 60, 70, 80, 90, 100. So we're adding 60 pence here, or we could write it as add 60 pence. And then what we do is we add these bits at the top that we've added on. I'm going to put this bit because it's quicker to just put it back in pounds. £3 plus 60 plus 1 is £3.61, and we've got the same answer, so that's great. Let's go to the next question. Here is a number sequence. Write the next two numbers in the sequence. So I've got 75, 50, 25, and then we've got 2 gaps. Seems to be going down. So I think that's take away 25. 50 take away 25 is 25. So it looks like I'm taking away 25 from each one. So 25 take away 25 is 0. And 0 take away 25 is negative 25. So I think that's what my answer is. Let's go on to the next question. So we have, right, let's have a look at this one. In 2012, there were 24,000. I'm just going to make that a bit bigger actually. It's a bit small. There we are. Okay. Question 8. In 2012, there were 24,372 schools in the United Kingdom. Round the number of schools to the nearest 100. Okay, 24,372. 24372, 24372. So those are the ones. Well, let's put that. They're the ones, or the units, the tens, hundreds, thousands, tens of thousands. And we've been asked to round the number to the nearest 100. Okay, so that's our hundreds column, to the nearest 100. So we look at the column we've been asked to and we look next door, and that's a 7. If it's 5 or more, we make that one go up, because actually 70 or 72 is closer to 400 than it is to 300. So my answer to this is going to be 24,400. Now, when you round it to the nearest 100, you turn these other numbers, these other digits, these other places into 0. We're rounding it to the nearest 100, and that's approximately 24,400 schools. Gosh, there's a lot on there. Nearly 25,000 schools in the United Kingdom. Goodness. Okay, so we have question 9. Here are some diagrams showing parts of a circle. Match each diagram to the name of the dashed line. So I'm going to do a rough circle here. That's our centre. It's a really bad centre. That's my centre of the circle. Now, okay, so we've got this part here, which is from the centre to the outside of the circle. We've got another bit here that goes all the way through the centre from one side to the other of the circle. And we've also got, let's put it here, we've also got this bit that runs all the way around the outside. I'm not sure if you remember the names of these things. So this is the circumference, and it's basically the perimeter of a circle. The perimeter of a circle has got a special name, and that's the circumference. So it's the outside of the circle. Now, which is the radius and which is the diameter? Now the radius is this bit here, is that bit there. That's the radius. And the one that goes all the way through from one side to the other through the centre point. The radius also touches the centre of the circle, and it's from the centre to the outside. And the diameter goes all the way through from one side of the circle through the centre to the other side of the circle. So the circumference, and it says the dashed line, so it's made it very clear that we're looking for the dashed line. The radius is this bit here that goes from the centre to the outside, and the diameter is going from one side of the circle through the centre to the other side of the circle. Okay, those are really helpful for high school to learn those names, because you'll do a lot of things with geometry and circles and different shapes at high school. Ooh. Just grab this and move it across. Okay, question 10. Ken thinks of a number. Okay, so Ken thinks of a number. He divides it by 3 and the answer 72. What number was Ken thinking of? Now, when you see a question like this, it's really helpful to think about what the inverse operation is. So if I said to you, something multiplied by 2 equals 6. Now you know that 3 times 2 is 6. If I did it the other way around and I said 6 divided by something equals 3. So 6 divided by 2, half of 6, or divided by 2, so 6 shared by 2 people, each person will get 3. If we did 6 divided by something equals 2, then we would be sharing 6 by 3 people and each person would get 2. If we did question mark divided by 3 equals 2, we can actually say 2 times 3 equals 6. 2 times 3 equals 6. So a number has been divided by 3 and the answer is 72. So we can do 72 multiplied by 3, which will give us the answer that's here, that Ken was thinking of. So let's do 72 multiplied by 3. And then we can try it back again and see what happens. 3 times 2 is 6, and 3 times 7 is 21. So I think the number Ken was thinking of, I need to get another colour. I think the number Ken was thinking of is 216, but let's test it. So it says, we're thinking it's 216 divided by 3 is equal to 72. Let me do that here. 216 divided by 3. How many 3's fit into 2? They don't. Cross it out and carry what you haven't used. We haven't used any of the 2. How many 3's fit into 21? 7 times 3 is 21. And how many 3's fit into 6? 2 times 3 is 6. Question 11. Write the number that is 1,000 more than 19,039. So 19,039. So this is the ones or the units, the tens, the hundreds, the thousands. So I'm going to add, it says 1,000 more. So I'm going to add 1 in the thousands column. Now, have a think about what you think this would be before it comes out. Have a think, sort of see if you can estimate what you think the answer would be. So 9 plus 0 is 9, 3 plus 0 is 3, 0 plus 0 is 0, 9 plus 1 is 10, 1 plus 1 is 2. So I think the answer is going to be 20,039. Now you know that 20 comes after 19. So we've got 1 tens of thousands and 9 ones of thousands, and we're adding ones of thousands. So it's 9 plus 1 is 10, and the 10 plus 10 makes it 20,039. Write the number that is 100 less than 19,039. I'm just going to change the colour. So we've got to take away 100. 19,039 take away 100. 9 take away 0 is 9. 3 take away 0 is 3. 0 take away 1. Go next door, cross out the 9, turn it into an 8 and carry 1. 10 take away 1 is 9. 8 take away, there's nothing there, so I'm going to, we could put zeros there because they could be placeholders, but we haven't got digits there. So 8 and 1. So I'm pretty sure the answer is 18,939. And if I wasn't sure, I could add. So I could say 18,939, and it says 100 less, so I'm going to add 100 to check and see if it gets back to this number. Oops. 9 plus 0 is 9. 3 plus 0 is 3. 9 plus 1 is 10. 8 plus 1 is 9. And 1. So I've got 19,039. Yes, that's right. Brilliant. Okay, right. This might be a bit tricky. See if I can use something. Number 12. Draw all the lines of symmetry on this shape. I'm going to try and do it on this. Yeah, that'll work. Okay, sorry. Put it down here. Okay, so that's one line of symmetry because I'll talk about it in a minute actually. So that's one line of symmetry, and then I'd say, right, I'm just there. I'd say that's another one there. I would say there's just two lines of symmetry there. Now, a line of symmetry is when, I mean, you probably have heard of it called a mirror line. So it's basically when one side looks exactly the same as another side. So if this line here was a mirror line, then we should be able to look that way, stand in the middle, look that way, and look that way and see the same thing. And here as well, look that way, and see the same thing. And this bit. In the same way, choose a different colour. Let's go for that one. In the same way, if we were choosing this line here, then we should be able to look that way, and they look the same. And all the way across there, and all the way across there, and then this bit as well, and all the way over to here as well. So it's just looking at a shape, isn't it? And working out where those lines are. So let's pop them in again. I'm just going to sketch this one in here. So they look the same both sides, and I'm just going to sketch this across here. Now, I haven't used a ruler. I just used things to do today. I recommend you use a ruler. Let's see if I can match it up. So there you go. So you'd just do that, wouldn't you? Making it, but you wouldn't do it as thick as me because it's a lighter line. I'm going to try it. So I haven't got the one with my screen. So It's a black screen down here, so I can only look there. Okay, so I'd say those are your mirror lines. Well done. Okay, let's have a look at the next question. Question 13. 1/5 of a number is 22. What is the number? 1/5 of a number is 22. So let's think, if I had a circle and I divided it roughly, very roughly, into 5 parts, 1, 2, 3, 4, 5, and 1/5 of the number is 22. That means that each section is the same. If I did it, and I know some of you will be doing bar modelling, and you had, I'm going to have to add a bit more to this. Okay. And that's a little bit uneven, isn't it? To say the least, very uneven. We've got 1, 2, 3, 4, 5 parts, and one part, 1/5, that's 1/5, one part out of 5, and the number is 22. What is the number? So each one of these is going to be 22 then, because 1/5 of a number means that if you've got 1/5, how many fifths are in one whole? So 1/5 plus 2/5, 3/5, 4/5, 5/5. And if you had, okay, say there was a pizza and it was cut into 5 parts and all 5 parts were eaten, how much the pizza is eaten? The whole pizza. Okay. So here we've got this as well. All right, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and it equals the whole thing. Now, how many 22s have we got here? We've got 5. And I mean, I know we've got 10 on these two, but altogether in one area and one thing, we've got 5. So if each of one of these is going to be 22, we're multiplying 22 by 5, aren't we? So let's do that. 22 multiplied by 5. 5 times 2 is 10. 5 times 2 is 10, add 1 is 11. So I think the answer is 110. Now, how could we check if we wanted to make sure we were right? If I write, I'm just going to rub this out actually and use this space. If I write here 5 multiplied by 22 is equal to 110. And that means 110 divided by 5 should equal 22. But it also means that 110 divided by 22 should equal 5. So I'm going to do that here. I'm going to do 110 divided by 5. How many 5s fit into 1? They don't. Cross it out and carry what you haven't used. How many 5s fit into 11? Well, 2 times 5 is 10, but that says 11, so there's 1 left over. How many 5s fit into 10? 2. So I've proved that 1/5 of a number is 22 and 1/5 of 110 is 22. Well done. Question 14. Let's have a look at this one. So just says measure angle A. So I'm going to grab my protractor and I'm just wondering where to put it really. I know that when you have a protractor, that cross needs to be somewhere on the angle. So that there, if I put it there, it doesn't measure anything. It just measures sort of the angle on the other side. What we've got to do is get this bit here, you see this bit here, to be on that A. So I've got to turn it around, and then we can either align it here and measure from the 0 round. So we either measure from the 0 around, let me just line it a bit better than that. So we measure from the 0 around to here. So I've got, it's about 130, 131. If I put it there you go, it's bang on 130 there. But I can also do it this way. As long as I've got the angle A inside this little semicircle here, I'm covered. And the 0 needs to be sort of the line you should have coming through the center of the 0. It's going to be different actually, as long as the line is actually sitting on it. Sorry, I shake on my left hand. And now I'm going to read from the 0 around the outside part here. And can you see that ends up as 130 as well? So you can either have it this way round, and then read it from the inside, which is to 130, or you could do it this side. If you can hear my dog barking, apologies. She's just heard somebody talking outside. And then let's have a look. We just balance it. There. Then it's 130, and read it round the outside now to 130. So I am going to write a nice, very clear 130, and it's already got the degrees there for you. Okay. Oops. 130. It's a bit messy there, but you can see what it is. You can see that it's 130. All right, well done. Let's have a look at question 15. Here are 4 fractions. Write the fractions in the correct place on the number line. I'm just going to make that a bit bigger. Okay. I want to work out what this scale is first. I want to try and work out what's going on here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sections. So that's split into twelfths. So it's basically saying that 12 twelfths is equal to 1 whole. So where do you think 6 would be? Because 6 is half of 12. I'm wondering whether 1, 2, 3, 4, 5, 6. I wonder whether that's a half. And then I'm just thinking what a quarter of 12 is. Quarter of 12. Okay, if half of 12 is 6, then a quarter of 12 is going, right, if I divide a half by 2, then I should be able to divide 6 by 2. Because if I have half there, and then I split that into 2 quarters, or the whole into 4 quarters, but I'm just talking about half at the moment. If I split a half into 2/4, then I've halved the half, haven't I? So half of half is 1/4, and a half of 6 is 3. So I think 1, 2, I think that's going to be 1/4. So then 1, 2, that's going to be 3/4. Right. If I wrote here 2/12, sorry, I'm not looking at any of this at the moment. I'm just sort of doing what I would do, and they're coming out as, yeah, that's basically, those are the sort of fractions that people are going to ask you. So 2/12, if I was going to find an equivalent fraction, I would look at both numbers and I'd see that they're both even, which means I can halve them. And that equals 1/6. Okay, so that 2/12 is going to be 1/6 there. So what have I got here? I've got 1/3, right? Okay, so let's pop in what we know. We know, oh no, don't do diagonal lines. I'm thinking I haven't got very much space, but actually I've got more space than I think I have. Okay, so 1/6 is equal to 2/12, because we've worked out these are in 12ths. And 1/4 is equal to 3/12. 1, 2, 3 is 1/4. So 1/4 equals 3/12. So 2/4 is equal to 6/12. 3/4, 6, 7, 8, 9/12. And 4/4, or a whole, which is 12/12. Okay, so that works. So the 1/4 is going to be there. Now I know this is going to be half because that's 6/12. I'm just going to fit this one in. So I'm guessing, have I written something wrong there? Ah, I've done a transference error, look. That's when you sort of thinking about something and you put the wrong number down. Happens all the time, so it's just worth looking out for. Just sort of checking them off maybe. Maybe I should have gone, right, that's 1/6. Well, that's 1/4. That's 1/2. I've got a 1/3 left, so maybe that would have been helpful for me to do. All right, so I've got to work out 1/3 of 12 to know where to put it. So 1/3 of 12. Now there's two ways I could do that. I could do, I'm just going to rub these out. Don't move that now. I could do 12 divided by 3, or I could do, what else could I do? I could, I know that of is multiply, so I could do 1/3 multiplied by 12, and that's 12 wholes, so I could do that. So let's see, 12 divided by 3, 3's into 1, carry 3's into 12 is 4, or 1 times 12 is 12, and that's still 12 divided by 3, which is 4. Okay, what I'm trying to do is find out how many parts. So 1, 2, 3, 4. Okay, so 1/3 of 12 is 4. So I think that's where 1/3 goes. I've just done diagonal line again, haven't I? So let's count. So we want 3/3 to fit into the whole 12 parts. That's 3/3, and 3/3 is the whole thing. So we've got 1, 2, 3. No? Is 1/3 3? The third is 4. Okay. So 1, 2, 3, 4. That's 1/3. 1, 2, 3, 4. That's 2/3. 1, 2, 3, 4. That's 3/3. Don't know why the others went off. Oh, yeah. It's going to keep it on when you do it wrong, isn't it? I mean, come on. Yeah. So that's 1/3, that's 2/3, and that's 3/3. So we've popped those in. Well done. On to question 16. Let's make that a little bit bigger. Okay, one day last year, the rate of rainfall from 6:30 a.m. until 9 a.m. was 2 millimeters per hour. What was the total rainfall from 6:30 a.m. until 9 a.m.? Let's have a look at this. So we've got 6:30 a.m. and then 9 a.m. I'm going to put 7 a.m. in the middle. Okay, so 7, 8, 9, there's 2 hours there, aren't there? And this is half an hour here, a bit small, but one day last year, the rate of rainfall from 6:30 a.m. until 9 a.m. was 2 millimeters per hour. So 2 hours means there's 2 times 2 millimeters. Okay. And then per hour, 2 millimeters. So half an hour is going to be 1 millimeter. So 6:30, 7:30, 8:30, 9, 2.5 hours. So we've got 2 lots of 2 millimeters, which is 4 millimeters. And then we've got 1 millimeter. So I think that the rainfall, the total rainfall, is going to be 5 millimeters. On to number 17. Number 17, the manager of a flower shop orders 4 boxes of red roses. So red roses, 4 boxes. Okay. There are 50 roses in each box. The manager makes bunches with 6 roses in each bunch. What is the greatest number of bunches that can be made? All right, so 4 boxes of red roses. Now it says that one box has 50 roses. So that means that 4 boxes, so 1 times 4 is 4, so 50 times 4, well 2 50s are 100, so 4 50s must be 200 roses. But the manager, he or she says that one bunch is 6 roses. So one bunch, I'm going to put B, one bunch equals 6. So 2 bunches is going to be 12. So 10 bunches, well 1 times 10 is 10 and 6 times 10 is 60. So we could do that and keep counting up until we get to 200. Or we could find out how many times we can fit 6 into 200. We could split it, couldn't we? Division. Okay, so when we do division, we're splitting a number into a certain number of parts. And our number of parts is going to be to do with 6. So we want to split 200 into sixes to see how many sixes we can fit into 200. So how many sixes fit into 2? They don't. Cross it out and carry what you haven't used. We haven't used any of the 2. How many sixes into 20? Well, I know 3 times 6 is 18. 18, 19, 20, and there's 2 left over. So 3 sixes are 18 with 2 left over. 3 sixes are 18 with 2 left over. 3 6, you can see what's happening here. Do you know what 0. Okay, do you know what 0.3 recurring is? Because this is what we're getting. It's a third. But this here tells us how many bunches we can make altogether. We can make 33 bunches, and we've got some left over. But those leftover parts won't make another full bunch. So this is your answer. Now let's just test it and see. Let's just see. I'm just going to put that cursor back up there. Let's just see. Now I'm just going to get rid of this. So I've got a bit of space. I wonder what 33 multiplied by 6 is. 33 bunches, and each bunch has 6 in it. 6 times 3 is 18. 6 times 3 is 18. Add 1 is 19. Ah, okay. So there's 2 roses left. And that would make sense because a third, and that's what this is, a third of 6 is actually equal to 2. And there's 2 left over. So what we'd need to do is we'd need to have 4 more to make another bunch. So it says, what is the greatest number of bunches that can be made? We can't make 34 because this is all we've got left out of the roses. We can only make 33. So the answer here is 33. Okay. Let's have a look at number 18. Make it a tiny bit bigger. A cinema sells tickets at 3 different prices. 1/20th of the tickets are price A. 3/5 of the tickets are price B. The rest of the tickets are price C. What fraction of the tickets are price C? Now, this is going to be to do with equivalent fractions because we have fractions with different denominators. We've got A, we've got B, and we've got C. Now, I'm going to put total here because this total is what helps work out the rest of them. So let's think. 1/20th of the tickets are price A. 3/5 of the tickets are price B, and we don't know how many are price C. Let's get a different colour. I said about equivalent fractions because you can't really compare fractions unless you have the same denominator. So I want to make them all out of 20. Now let's think, if they sold all the tickets, what fraction of the tickets have they sold if they sold all of them? Yeah, sold 100%. 100 out of 100, 1,000 out of 1,000, 20 out of 20. Because that number there is a bigger number, not a bigger fraction. It's a bigger number. We're going to make them out of 20th. So my total is going to end up being 20 out of 20 because that's all of the tickets. So what I'm going to do is make this fraction out of 20. But that means I need to make that fraction out of 20 so I can compare them. So I'm going to write 3/5 is equal to, I don't know how many 20ths. 5 times 4 is 20, and 3 times 4 is 12. So this here is the same as saying 12 20ths. So we have 1/20th, A is 1/20th, and B is 12 20ths. And because they have the same denominator, we can add the numerators. 1 plus 12 is 13. So we've got 13 20ths. So the rest of them are price C. So we've got the total 20 20ths, and we've got the price tickets A and B. We've got 1 and 12, which is 13 20ths. And we're going to have a denominator of 20, and our numerator is 20 take away 13, which is 7. So I think this is going to be 7 20ths. And we can't simplify that any further because 7 is a prime number. So the answer here is 7 20ths. Okay. Right, question 19. Write the missing number to make this division correct. So we've got 15,000 divided by something equals 75. Now I'm going to put my statement up that I use. I use these to work out. Oh, that's not very good, is it? I use this to help me to work out what to do. And you don't have to write all of these, but it just sort of helps to see. And it's sort of, I can look at it and compare them. So if I was going to call 15,000 my 6, and I don't know, and that could be a 3. So this I don't know is going to be a 2. So if I compare that, I can put 3 multiplied by something equals, but I don't know what that number is. Oh, what I could do, if that was a 2 and I was trying to get the 2, then I have to have the 2 at the side. So I could actually do 6 divides. I could do this number divided by this number to find out that one. So I'm going to transfer that information down here. I'm going to do 15,000 divided by 75, and that should give me my answer. Divided by 75. Now I want my facts for 75 to be up somewhere. So 1 times 75 is 75. 2 times 75, 2 times 40 minus 15, so it's 150. 3 75s is the same as adding 175 and 2 75s, so it's 225. 4 75s, 300, 5 75s, we'll just do for up to 5 75s, it's 375. So let's see if that helps. How many 75s fit into 1? They don't. How many 75s fit into 15? They don't. How many 75s fit into 150? 2 75s fit into 150, so 2. I'm taking 150 away. and I end up with 0. Okay, so maybe it's 2. Or maybe what do I do with these? Yeah, I put them up here. It wouldn't be 275s fit into 15,000, so it'd have to be 200. I wonder whether I could check. So we didn't need all that, which is really good. Glad I didn't go all the way. I wonder whether I could do 200 multiplied by 75 and see if it would give me 15,000. The 5 times 0 is 0. Ah, hang on a minute. I've got to put my other, there you go. 5 times 0 is 0. 5 times 0 is 0. 5 times 2 is 10. I'm multiplying by 7 now. Sure, I've got to... Ah, it's in the tens column. I've got to put my 0. 7 times 0 is 0. 7 times 0 is 0. 7 times 2, 2 sevens are 14. So we're adding them down, just change the colour. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. 4 plus 1 is 5. And 1, 15,000. Yeah, that's it. So the answer is 200. Okay, let us go down and look at number 20. All right, a little bit bigger. Write the 2 missing digits to make this long multiplication correct. Actually, it might be better to do it like this. Let's think. Well, 3 times 5 is 15. 3 times 3 is 9 plus 1 is 10. 3 times 2 is 6 plus 1 is 7. And 3 times something is 9. So I think that's going to be a 3. Let me go through that again. 3 times 5 is 15. So I've got my 15 there. 3 times 3 is 9. But I've got that 1. So that's made it into a 10. 3 times 2 is 6, but I've got that 1, which makes it into a 7. So then the only thing we've got left is 3 times 3, which is 9. Let's change the colours. I'll use orange. That'll be nice and clear. Right, so they've put the 0 down because they're multiplying by the 10. We don't know what that 10 is. But we know something times 5 is something ending in 5. And 5, so it's going to be, I'd say that digit, to make that into a 5, it would have to be a 1 times 5. 2 times 5 is 10. So it'd be a 3 times 5 is 15. 4 5s are 20, so it can't be that. Could be a 5 5s are 25. Can't be a 6 5s because that's 30. So it's going to be the odd numbers. It's going to be a 1, a 3, a 5, a 7, or a 9. Okay. So something times 3. Okay, but that's 7. Oh, so that could be a 2. No, it couldn't be a 2. If this was a 2, that would be 2 times 5, which is 10, and that's a 5. So that can't be a 2. And we've already said it can't be a 2, haven't we? So 1 times 5 is 5. 1 times 3 is 3. That doesn't work. So I don't think it's a 1. So we're not doing 1. So 3. Let's try 3. 3 times 5 is 15. 3 times 3 is 9 plus 1 is 10. That doesn't work. 5. 5 times 5 is 25. 5 times 3 is 15. Add 2, 16, 17. Oh, it could be a 5. Okay, so that was a 5. 5 times, so we've done 5 times 5 is 25. 5 times 3 is 15, add 2 is 17. 5 times 2 is 10, add 1 is 11, and that's 1, that's fab. 5 times 3 is 15, add 1 is 16. So I think it's 53. I think it's 3,235 times 53. And if you wanted to, you could work it out. Let's see if I'm right. 53. I've got a different way I could do it actually, but I'm not going to do it that way. I'll do it this way. We could do it the other way as well. Let's put our 0 in, put our plus here. 3 times 5 is 15. 3 times 3 is 9, add 1 is 10. 3 times 2 is 6, add 1 is 7, and 3 times 3 is 9. 5 times 5 is 25. 5 times 3 is 15, add 2, 16, 17. 5 times 2 is 10, add 1 is 11. And 5 times 3 is 15, add 1 is 16. So we've got 5. 0 plus 5 is 5. 7 plus 7, 2 sevens are 14. 9 add 1 is 10, add 1 is 11. 6 add 1 is 7. And 1. So we've got 17,000. So 17,100. That's not right. So we haven't got 17,000. So it's not 17,000, is it? I've put that comma in the wrong place. Let's count. 1, 2, 3. I think it's 171,455. Brilliant. 21. The height of the tallest person in history is 8 feet 11 inches. 1 foot is the same as 30 centimeters. And 1 inch is the same as 2.5 centimeters. Use this conversion table to calculate the height of the tallest person in centimeters. So we've got 8 feet and 11 inches. Okay. So 1 foot is 30 centimeters. We've got to convert it to centimeters. So 8 feet equals how many centimeters? If we've got 1 foot is equal to 30 centimeters. Now to get 1 to turn into 8, we could add 7, but that's not the way we do it. You have to do multiply, and 1 multiplied by 8 is 8, and 30 multiplied by 8, because what we do to one side we've got to do to the other. So 30 times 8, I'm thinking it's 3 times 8 times 10, because I could split 30 into 3 times 10, so I think it's 240, but let me just check. 8 times 0 is 0, because 0 times something, or something times 0 is 0. 8 3s are 24, yeah, so it's 240. So I think that is 240 centimeters. Okay, so let's look at the inches. I've got 1 inch is equal to 2.5 centimeters, and these are approximations, but this is the information we've been told. Now we've got 11 inches here, so 11 inches. 1 multiplied by 11 is 11. So what is 2.5 multiplied by 11? Okay. I'm going to split 11 into 10 plus 1, because 10 plus 1 is 11. And I'm going to do 10 times 2.5, and I'm going to add 1 times 2.5. 10 lots of 20. 10 lots of 2.5 is 25. And 1 lot of 2.5 is 2.5. And then we add those together. We've got 5 plus 2 is 7, and 2, we've got 27.5. Now we need to add those together. So we'll do it over here. So 240 plus 27.5 is, oh, I'm moving myself. If I balance that, and I can say 0 plus 5 is 5, 0 plus 7 is 7, 4 plus 2 is 6, and I'm just going to squeeze it over here out the way of my picture. So I think that the height of the tallest person in centimetres is 267.5 centimetres. Let's look at the next question. Oh, okay, so we have, let's just make that a bit bigger. Here is a regular hexagon. The area of the large shaded triangle is double the area of the small shaded triangle. Let's make that clear. So let's just sketch this. And then this one. The area of the large shaded triangle is double the area of the small triangle. So we could say that's times 2 that way, and that's divided, oh no, that's not right. That's divided by 2 that way, possibly. Ooh. What fraction of the whole hexagon is the shaded area? The first thing I'm going to do is sort of split it up into parts. All right. So we could say that's one part. So that's one part. No, that's not helpful, is it at all? That's another part. And that's another part. That's another one. And that's another one. And this is another one. Okay. So if we're looking at each of these larger triangles, which look like isosceles at least, possibly equilateral, but definitely isosceles, because that side is the same length as that side. We've got 1, 2, 3, 4, 5, 6. So we've got 6 of these, and this part is half of it, isn't it? So I think we've got 12 of these. So out of the whole shape, then this part is 1/6 of the whole shape, because there's six of them. So one of them is one part out of 6. And this one here, because there's 12 of them and we've only got one of them, that's 1/12 of the whole shape. So what fraction of the whole hexagon is the shaded area? So I would say that we've got 1/6 of the shape plus 1/12 of the shape. Now, if we decided to make the denominators the same, then what we need to do is we need to make 6ths into 12ths. And I'm going that way because this is a 1 at the top. So I don't really want to put half at the top. So 6 times 2 is 12. and 1 times 2 is 2. Because it's over the equal sign, what we do to the top, we've got to do the same to the bottom. So 6 times 2 is 12, and 1 times 2 is 2. So this is 2/12 of the shape. So I'm going to rewrite it. This is 2/12 plus the other one is 1/12, which is 3/12 of the whole shape. Now I know that 3's fit into 12. I know 3 is a factor of 12. So let's see if we can do an equivalent fraction, because they'll want it in its simplest form. So I know that 3 fits into 12, so I'm going to divide the top and bottom by 3. How many 3's fit into 12? 3, 6, 9, 12, so 4. 3 divided by 3 is 1, so my answer is going to be 1/4. Let's move that over a bit. Okay. Question 23. A small box contains 650 grams of cereal. So this one, it says there, doesn't it? It says 650 grams. The large box contains 20% more cereal. Right, I'm not going to ignore this. I'm going to come back to this in a minute. I just need to sort out how much is in the large box. So 20% more cereal means it's 20% more than the 650 grams. So what I want to do is find out 10% first. Now 10% is the same as saying 10 hundredths. And if we simplified that fraction more and we divided the top and bottom by 10, we've got 10 divided by 10, which is 1, and 100 divided by 10, which is 10. So we're looking for 1/10 of this 650 grams. Because this says 20% more cereal than that one. So we're looking at 20% of this. If you know that 20% is equal to a fraction, then you could also use that, and I'll mention it briefly in a minute. So 1/10 of something is 1 part out of 10, so we divide by 10. So if we divide this by 10, it goes down 1 place value, which is 65 grams. So 20% is going to be 2 lots of 65 grams. So 2 times 5 is 10, and 2 times 6 is 12. Add 1 is 130 grams. So I think the large box has, let's just find a different colour, 650 grams plus 130 grams is equal to 780 grams. I think the larger box has 780 grams of cereal in it. If I'd done it this way, this bit here, I could have done 20% is the same as saying 20 hundredths, because anything with a percentage sign means it's divided by 100. It's still part of a whole. Now I know that I can divide the top and bottom by 20. 20's into 20 is 1. 20's into 100 is 5. So I could have found 1/5 of it. I could have basically, it might have been a choice you'd made. I could have done 650 divided by 5 to find one part. And I've still got 130. Now let's have a look at, just put that up there. So one portion of cereal is 40 grams. How many full portions are there in the large box? Full portions. So I have, and it says the large box. I've got to find out how many 40 grams fit into 780 grams. I want to find out how many 40 grams fit into it. And when you're trying to find out how much of a number fits into another one, it's finding repeated parts. So it's a lot to do with multiplication, but also it's to do with division. So what we're doing is we're doing 40 multiplied by something is 780. But then that also means we're doing 780 divided by 40 to find out what that is. So, just choose a different colour. Let's go for that one. So I'm going to do 780 divided by 40. And I know 1 times 40 is 40. Just put a few facts up here to help me. Forties into 7. No. 40s, how many 40s fit into 78? 140 is 40. 8 take away 0 is 8. 7 take away 4 is 3. We've got 38. So I'm going to bring this 0 down, because 40 doesn't fit into 38, but 40, let's see if it fits into 380. So I've got to carry on going. So we've got 240, we've got 280, 90, 300, 310, 320, we've got 20, 30, 40, 50, 60, and then 400. So we've got 7 lots, 8 lots, 9 lots, and 10 lots. So it looks, whoops, let's go back. It looks like it is this one. 9 times 40 is 360, because it says full portions, and 1 portion is 40 grams. So 8 take away 6 is 2, 3 take away 3 is 0. So we have 20 grams left over, which is half a portion. So I know 19 full portions fit into that box. Let's look down at the next question. So we're on, whoops, where are we? So cursor, question 24. Let's have a look. Oh, it's a pie chart. Oops. Right, let's have a look. 1,200 pupils were asked this question. Let's just check that's there. How important is it to have a break when using a screen? This chart shows the results. So 12% say not important, 41% say quite important. Some children say, or pupils say, very important. How many pupils answered very important? Okay, well, it's a whole circle, so the whole of it must equal 1 because it's a whole. But what they've done is they've used it as percentages. So what's 1 as a percentage? So it's 100%. 100% is the whole thing. Well, we've been given 12% and we've been given 41%. And we've been given a very important, but we don't know what that is, that equals 100%. It's got to equal the whole thing. So 41 add 10 is 51. Add 2, 51, 52, 53%. 40, 50, 52, 53% plus the very important equals 100%. Okay, so I'm going to find the difference between 100 and 53, and hopefully you're yelling at me at the screen to tell me what to do, that you know what it is. 47. So now it says 47%, and we know 47% and 53% should equal 100%. 7, 8, 9, 10, 5, 6, 7, 8, 9, 10. Yes. So I now know that this answer is what goes here. Okay, I'm just going to get rid of this. So I've got some space because it looks like I've got another question. Okay, it looks like this question is what I need to answer. How many pupils answered very important? And we've got percentage, but it must be 47% of 1,200 pupils. Okay. Right. Well, let's just, I've got here about 100% being the whole, so I'm going to use that. Okay. So 100% is 1,200 pupils. So 50% and possibly 10% might help us, and 1% might help us. So let's find out some of these facts. So 50% is half of 100%. So half of 12 is 6, so it's 600 pupils. Right, so to get 10%, I could either divide 50 by 5, or I could divide 100 by 10. I might do that. I might divide that by 10. Now remember, we're in a place value system that is decimal, so it's to do with tens. So we go up a number, up a place value if we multiply, and down a place value if we divide. So we're dividing by 10. So that's going to be 120, isn't it? And then we're dividing by 10 again. 10 divided by 10 is 1. So 120 divided by 10 is 12. Right, I'm going to use these facts to help me. 47% is the same as saying 50% take away 3%. Do you agree with that? Do you agree that 47% is the same as saying 50% take away 3%? 50% is 600. And 3% is, if 1% is 12, 1% times 3 is 3%, and 12 times 3, 3 12s are 36. So we've got 50%, this one here, whoops, take away this one here. and that gives us 47%, so 36. So 600 take away 36. 10 take away 6 is 4, 9 take away 3 is 6, 5 take away, I think it's 564 pupils answered very important. That was a really tricky question, actually. That's tricky. And we have, is that the last one? Let's have a quick look. I don't know, I suspect there might be another one, but, oh, there's two more. Two more and then we're done. There are 25 sheets of paper in a small pack. Okay, so small is 25. Okay, large, 25 sheets of paper in a small pack. There are 500 sheets in a large pack. How many small packs make one large pack? Right, so I've got to work out what I multiply 25 by to make 500. We could do 500 divided by 25, or we could do 25 times something equals 500, which I'm going to do that way because I know that 25 times 10 equals 250, and then I know 250 multiplied by 2 is 500. So I look at those multipliers, the numbers that we've just multiplied by, and I'm thinking times 10 times 2. Well, 10 times 2 is 20, so maybe it's times 20. Let's think. Could it be times 20 if it's times 10 times 2? But if times 10 times 2 was times 12, then it'd be 25 times 10, which is 250, and 25 times 2, which is 50. So that would make 300. So times 10 times 2 must be 10 times 2, which is 20. So that is my answer. How many small packs make one large pack? I think it's 20. And then it says the mass of the paper in the large pack is 2, right, so the mass of the large pack is 2.4 kilograms. What is the mass of one sheet of paper in grams? Goodness me. The mass of the paper in the large pack is 2.4 kilograms. Let's put the mass up here. What is the mass of one sheet of paper in grams? So, all right. So kilo means 1,000. 2.4 kilograms means 2.4 times 1,000 in grams. So we've got to multiply 2.4 times 1,000. And because we have 3 zeros there, it means it moves up the place value system 3 times. So if I do that, and we know it moves up, so we don't need those, it's going to go up 10 times 10 times 10. So the 2 goes to that space, and the 4 goes 10 times 10 times 10. We don't leave the 4 behind. And then these two spaces, we have to put zeros here. So that is equal to 2,400, which means it's 2,400 grams. Let me just put the, let's put this, I normally put 1 kilogram equals 1,000 grams. So my multiplier here is going to be 1 times 2.4 is 2.4, and 1,000 multiplied by 2.4 is 2,400 grams. Right, it says 1 sheet of paper. Well, the large pack contains 500 sheets of paper. So we've got to work out how many 500s fit into 2,400. And when we're talking about fit into, we usually look at division. So we're doing 2,400 divided by 500. So 2,400, I'm going to put some zeros, divided by 500. So we say, how many 500s fit into 2? They don't. How many 500s fit into 24? They don't. How many 500s fit into 240? They don't. How many 500s fit into 2,400? They do. So we've got 500 is 1. 2 500s is 1,000. 3 500s is 1,500. 4 500s fit into 2,000. And then 5 500s fit into 2,500. So we want this one, don't we? We know 4 lots of 500 fit into 2,000. So we take off what we've done. 4 take away 0 is 4, and 2 take away 2 is 0. So we've got 400 left. So that's 100 less than the 400 that we need. So let's bring this down. Okay. How many 500s fit into 4,000? Goodness. Well, if 4 500s fit into 2,000, then 8 500s fit into 4,000. Exactly. Absolutely exactly. So we've used all of that. That's done. So our answer, I think, is going to be 4.8 grams per sheet of paper. Goodness, that was tricky. Well done if you've done that one. One more. Oh, we've got a maths one again. Let's have a look. It's to do with formulae. Let's have a look. So we have question 26. This formula is used to estimate the mass in kilograms of young children. We've got mass is equal to 2 times age. Oh, age in years. That's a bit, it's gone a bit funny. Age plus 5. So the mass is equal to 2 times, Stefan's sister is 4 years of age. So it's going to be 4 plus 5, 5, 6, 7, 8, 9. So the mass of Stefan's sister, I think, is 18. So what I did was I put this 4 years of age here because it says age in years. There. So I put the 4 there, and then I did 2 times, that's a bit messy now, isn't it? I put 2 times 4 plus 5. And 4 plus 5 is 9, and 2 times 9 is 18. We've got to think of Bodmas here, or Bidmas. It's Bodmas at your point there mainly. 2 times age in years plus 5. So we've got to sort out what's in the brackets first, which is 9, and then 2 times 9 is 18. So use the formula to estimate her mass. So we're estimating her mass is 18 kilograms. But the mass of Megan's brother is 16 kilograms. Okay. So we've actually been given the mass. So Megan's brother is 16 kilograms is equal to 2 times his age plus 5. Use the formula to estimate his age. Right, well, if we're doing 2 on that side, if we're doing double that, if we're doing 2 times that, then surely we're doing half of that to balance it. If it's 2 times on one side, it's going to be half of the other. So I'm going to put 8 kilograms on that side. And now I just need to work out this bit here. So if it's double on one side, it's got to be half on the other, because we're sort of, Oh, I wonder if it's add 5 on that side. I wonder, I'm just going to take off the kilograms there because it's making it more confusing. If it's add 5 on that side, maybe it's take 5 on that side. So maybe if I leave years there and I take 5 away from that side and I take 5 away from the other side, I wonder if he's 3. Let's put it back into the formula to see if it works. Okay, I'm going to put 3 here now. And let's just get rid of these and find out. So we've been told his mass is 16 kilograms. So if his age is 3, 3 plus 5 is 8. And then 2 times 8 is 16. 16 is equal to 16. So I think he is 3 years of age. Let's just think. I think this is the last one. Maybe it isn't. Is it the last one? Yeah, I think this is the last one. Yeah. So, well done for that. And yeah, keep up the good work. Well done. Bye.